One of the last projects, or one of the last wiring projects that I've needed to take care of on the D100 is wiring the power to the external fuel pump. Now, if you go back and watch some of my previous videos, you'll know that I've pretty much been building this truck to accept fuel injection. I mean, I went and installed an external fuel pump and filter in the frame rail back by the gas tank. I also ran new fuel lines at that time. I also moved my gas tank from under the driver's side of the cab to the back of the bed, or under the back of the bed. That wasn't for fuel injection, that was just mainly for the exhaust system that I want to run. But I've been kind of holding off on doing the wiring for the fuel pump because I wasn't sure if I was going to stick with the fuel injection or run my carburetor for now. So I've decided that I'm going to run the carburetor for now, and that's mainly just for the engine break-in. So I've already gone and installed an external fuel regulator to take the fuel pressure out of the fuel pump and knock it down to the pressure needed by the carburetor. Now I've went ahead and installed the power for the fuel pump. Now, I could have done that just by taking the power wire, going to a switched power source, and that way when I turn the ignition to run, that it kicks the fuel pump on, fills the bowls of the carburetor, and starts up. But that's not really the correct way to do it. So here's what I did. Before I get into exactly how I wired the fuel pump on this D100, I wanted to talk about the wiring in general. All the wiring outside of the cab has been replaced. I've completely rewired the entire engine bay, all the wiring going to the back of the truck, it's all brand new. Now, I've made a few changes, improvements maybe, to the wiring. So when I was taking out the old wiring, right in this general area there was a splice. I think it was like 6 or 7 wires that it was all the switched power. When I was taking the wiring harness out, that splice pretty much fell apart. So I replaced that splice with a junction block. I've gotten these junction blocks out of, I believe they're like late 90s Chevy pickups. They're usually on the firewall, up on the passenger side, top of the firewall. I usually grab a few every time I go to the junkyard. They're good to have, they come in handy. So this one here is actually for the switched power. So everything that was in that splice now goes to this junction block. It just makes it more convenient, makes it more reliable, because now everything is attached with terminal lugs instead of relying on a crimp or a splice or a solder joint. I also added one here for constant power. So this one basically is connected directly, so the battery is connected to the starter relay, and then there's a wire that comes directly to here. At this junction block is constant 12 volt, and this one is switched 12 volts. So this one is only when the ignition's on. So like I said, I could have run the power for the fuel pump directly from the switched power. That way, you turn the truck to run, fuel pump turns on, starts pumping gas, does its thing. But like I said, that's not really the right way to do it. So here's what I did. I used a relay. This happens to be, let's see if it'll focus here, a Tyco Electronics 30 amp relay. What this does is allows, well here, I drew this up and let me use the drawing here that I made. So here's the bottom of the relay. So you can have your constant 12 volts coming here on pin 30. And then you can have your switched power come here on switch 86. So what this does, and then on pin 87 is actually your out to the fuel pump. And then 85 is just ground. So what this does is there's always 12 volts sitting here at pin 30. And what happens is when you turn the ignition on, it gets power from this switch source and allows the 12 volt from the battery circuit, from the battery junction, to go out to the fuel pump. So what that does, puts now the current for the fuel pump pulling directly from the battery instead of the switched source. So by moving the power from what would have been the switch source to directly from the battery, it just makes it a more reliable circuit. Instead of putting a lot of, it's not that it's that much current, but it could be if that fuel pump ever fails, if it ever gets clogged and starts to draw more current, it could cause other issues. Now I did add a fuse to it, and I'll show you that in just a second where I did the install. There is a fuse on the input power to the relay. That way, if the pump ever does start to fail and starts to draw more current, that fuse will go long before the relay does, or long before anything else in the truck goes. But by moving it from a switch source to directly from the battery, it just makes for a more reliable circuit. Let me show you what I did on the firewall. I mounted the relay to the firewall, and let me show you the wiring that I did there. So there you can see the relay that I installed on the firewall. It's right there next to the voltage regulator. Let me zoom out and you can see exactly where it is. So that red wire coming in the bottom is actually has a 10 amp fuse in it, and that's the power, that's the 12 volts coming from the battery junction block. And then this blue wire here is what goes down along the fuel return line back to the pump. So let me show you exactly how this thing works. All right, so now I've got the battery hooked up, keys in the ignition, ignition's off. Now, turn it to, that's the accessory. And that was run, kicks the fuel pump on. That's really it. So there's the more correct way to wire an external fuel pump. Actually, that's the way you should be wiring pretty much anything that could have a significant current draw. If you're into off-roading and you're installing some HID lights, you're gonna wanna run those through a relay. If you're gonna be running, let's say, an electric radiator fan, you're gonna wanna run that through a relay. Something that can support the inrush current of that fan starting up, rather than run that through your existing wiring. You're gonna wanna run new wiring, run it through a relay. That way it pulls directly off your battery and not through your existing wiring. Pretty much anything that you're gonna wanna run that, again, could have a significant draw, you're gonna wanna put that directly on the battery. It just makes for, again, a more reliable circuit. So, thanks for watching. Hit the subscribe, hit the bell so you get notified when new videos come out. I'll catch you on the next one.